Okay, so the periodic table. People that you need to know, there's two people. Dmitri Mendeleev. He was the first person, the first scientist to actually organize elements into a table. He listed the elements in vertical columns. He arranged them by their properties, and he predicted physical and chemical properties of elements that were not yet discovered. And he arranged elements by increasing atomic mass. The next person was Henry Moseley. He arranged elements in order by increasing atomic number, and that is the current arrangement that we have right now. So all of the elements are in order by increasing atomic number. Some terms you need to know. A period is another term for a horizontal row on the periodic table. There are 7 of them. We have been calling these energy levels. So period, row, and energy level, that's all referring to the same thing. It's the horizontal row. A group or a family is a vertical column on the periodic table. And we've got special names for some of those columns. And the periodic law states that elements are arranged in order of increasing atomic number, which creates a pattern in their physical and chemical properties. So the biggest thing is that because they are arranged this way, we can see different patterns in the way that the elements react. So I said that the groups are families, so those vertical columns, some of them have special names. So if you notice on your periodic table, not on this example here, yours should be listed little numbers like 1A, 2A, like that, across your periodic table. So group 1A, those are the alkali metals. Group 2A is the alkaline earth metals. 3A is the boron or aluminum group. 4A is the carbon group. 5A is nitrogen group. 6A is the oxygen or chalcogen group. 7A is halogens, and 8A is noble gases. So these correspond. Okay, that our group 1A alkali metals, it's everything below hydrogen. Hydrogen is kind of a loner and doesn't really belong anywhere because hydrogen is a gas. It's not a metal, but it is in that column. So just know that hydrogen is not part of the alkali metals. So we've got 1A, 2A, and then 3A, the boron or aluminum group, starts over in our P block. And these should correspond with your periodic table with the A's numbers. There's a lot of arrows. Okay. Also, if you notice, a little note that I put, that the number before the A tells you how many valence electrons all of these elements will have. So, for example, in the oxygen or chalcogen group, this group is 6A. And so that means that every single element in this column has 6 valence electrons. So it's a good way to check your Lewis dot diagrams after you've done your orbital notation and all that stuff, to just double check to make sure that you have the correct number of valence electrons. Okay, so those are the special group or family names. There's also a way that we can divide the periodic table into 3 sections. So the 3 sections are representative elements, transition metals, and intertransition metals. Our representative elements are the S and P block elements. So all of these, those are considered representative elements. Transition metals are our D block, and intertransition metals are the F block, or those ones on the very bottom. So although we do have special names for a lot of those groups, this is a way that the periodic table can just be sectioned into 3 different sections. To figure out, there's also a way to show you which elements will accept electrons and which will donate electrons, and that will make a lot more sense when we start talking about bonding and making chemical compounds. But all you need to know right now is that these elements here, these will donate electrons, and these will accept electrons. That's all you need to know for right now. In class, I'll show you what this group does and then why our noble gases don't accept or donate. But for right now, just to be able to classify on your chart, just know that that big section is going to donate, and then that smaller section, so group nitrogen group through the halogens, those are going to accept electrons. The last thing that you need to know about is atomic radii, or the atomic radius of elements. And this is basically just a fancy way to say the size of the atom. The group trend is that it is going to increase, the atomic radii increases as you move down because you are adding energy levels, so that therefore the electron cloud size is going to increase because you've got more energy levels. So it is going to increase as you move down. The period trend is that it increases as you move from right to left. So it increases, or it gets bigger as you move from right to left. So if we look at what element is going to have the largest atomic radii, it's going to be on the far left-hand side and all the way down. So that element, francium, has the largest atomic radii. And if you need to compare which element or which atom would be bigger, you just follow this trend. So if you had calcium and selenium, alright, calcium would be bigger because it is farther to the left. If you had lithium and potassium, potassium would be bigger because it's farther down. So just follow those trends when you are comparing sizes of atoms.